Hey everyone, in today's lecture we're going to be discussing space and the illusion of space. It's one of the most important lectures we have during the entire semester, and it is the very first of kind of what I call our trifecta. We have three major formal elements: line, space, and color. We're going to be dealing with line and color in the next few lectures, but today the idea of space and how artists can create three-dimensional space on two-dimensional surfaces is pretty fascinating. So join me, we're going to head over to the lecture and I'll tell you all about space. Our lecture today deals with space, and more importantly, the illusion of space. A lot of these early terms we're already going to be familiar with, and my goal is to give some exact definitions to them. So for positive and negative space, that deals specifically with three-dimensional art objects. This would be objects such as sculpture and ceramics, glassware, and jewelry. And let's not forget architecture. That's one of the most important mediums that we deal with positive and negative space. The definition of positive space is anything that can be seen, felt, or touched. Negative space can just be defined as empty space, or the void between the objects or their pieces. The Watchtowers has a combination of both positive and negative space, and this is one of the Southern California landmarks that we have. The artist, Simon Rodea, this is the only thing that he created. It's really a fantastic artwork. It's something between sculpture and architecture. He did have a house on these premises, but in the 1960s it burnt down. There is a video that is going to be linked in the description box. If you are taking one of my classes, it is also linked on the Canvas site under further exploration. Take a few minutes and learn about the Watchtowers. Again, this is an amazing place, and unfortunately, we don't know a whole lot about Simon Rodea. He's kind of a mystery. He was an Italian immigrant. He broke his hip falling from the towers as he was working on them, and after he broke his hip, he moved up north and moved in with his brother. This is around the late 1950s, and that's really the last we ever hear from him. So he does have kind of this mysterious persona. Now, normally art is positive and negative to certain percentages, but occasionally we do have a fully positive sculpture or other artwork. In this case, we have this great work called Menkari and His Wife. Menkari is one of the pharaohs that have one of the pyramids on the Giza plain. So his grandfather was Khufu, and he's got the very first pyramid that you see in the upper right. The Grand Pyramid, still with some of the granite facing stones, that is Khafre, that's his father, and then Menkari has the smaller pyramid that's closest to us. This work is also made out of diorite, and diorite is one of the most difficult minerals to carve, and that's why this sculpture looks so nice, even though it's like 4,500 years old. But you can see that between the bodies, between their legs, between the bodies and the arms, we still have some solid material. So there is no real negative space in this sculpture. Opposite of that, we do have kind of some interesting works. I kept thinking about, like, what would I consider something that is 100% negative space? And the only one that I came up with was actually a series by Robert Barry, where he would take these tanks of basically inert gases and let them go into the atmosphere. So we have helium, basically he goes out to Death Valley, turns on the tank, lets it go, and he's taking a picture of the atmosphere. And then we also have argon as well. But most of the time, the artwork that you're going to come across is going to have both positive and negative aspects. When we switch over to two-dimensional media, we still have positive and negative space, but we refer to it under different names, figure and ground. So figure is positive, ground is negative. Think of ground as short for background. Two-dimensional elements would be like drawing, painting, photography, and printmaking. And all these mediums we'll talk about later on in the semester. What's exciting about figure and ground, as well as positive and negative space, is that the viewer really just concentrates on the positive, on the figure. But artists are kind of a different breed of people. And they are not only concerned with the positive, they're also concerned with the negative or ground. When we look at this work here, the artist is interested in that arch, in that leg that goes up to the upper right, but he's also interested in that white space to the right, that white space under the arch as well. When I ask you on an exam which is more important, positive or negative, the answer is actually both have equal importance. Even though as a viewer, we're looking at the positive or figure, the artist says both are important. And by the way, this is just the letter R on its side. Franz Klein writes that I paint the white as well as the black, and the white is just as important. Our next term is pictorial plane, or what some people call the picture plane. This term is going to refer to the surface of the canvas or other two-dimensional surface, such as wood, such as illustration board, photography prints, anything like that, anything two-dimensional, we call the pictorial plane. Now, back during the Renaissance in 1435, there's this guy named Leon Battista Alberti. And he writes this famous book called On Painting. In fact, the original copy there off to the right, it is still in print today, and you can find it at most places like Barnes & Noble or Amazon or your independent bookseller. And in the book, he says that looking at a painting should be exactly the same as looking out a window. And so what he's asking us to do is to pierce the pictorial plane, make that two-dimensional form three-dimensional so that it looks something more like this here. There are 6 illusionary techniques that we're going to talk about today, and some of them are very simple. Scale, overlapping, vertical location, all of those we've been dealing with since grade school. They're so easy. But when we start to add the term perspective, whether it's atmospheric, amplified, or linear, we start getting a much more complex idea on how to create space. It's also a much more authentic way of creating space for the artist. So we're going to talk about the 3 easy ones first, and the first one is scale. With scale, it states that objects closer to us appear larger than those that are farther away. In class, I would play you the video of Grover here. I'm also going to link it down below in the description. Once again, if you're taking this class with me in person, it's in the further exploration section, and it's Grover's near and far, where here he's standing closest to us. Objects closer to us appear larger than those farther away. And when he goes far, you see him just down at the very bottom of the screen. Scale plays a big part in this painting here. When you look at the tree line that's off to the left, you can see how they diminish in size, basically leading us down this snow-covered pathway or roadway. And even though that first tree off to the left is just as far away from us as that tree that's the furthest one in that line, it gives us the idea or depiction that there's a lot of space in this painting because we see the trees smaller in scale. So this is just one of the easier ways of creating space. I'll show you a few other works where scale is determinate for the space. And what artists are trying to do is reproduce the way that we see. These are some of my past students. Off to the left, Ibrahim. Rebecca to the right, Serene. You saw her jumping in front of the Eiffel Tower in the Roles of the Artist lecture. And then one other girl in the back. And you can see how they've diminished in size. This is how scale works. And so when it happens in real life, the artists are trying to copy that into artworks. Next, we have overlapping. Objects closer to us cover or hide objects that are farther away. So in this painting here, off to the left, I have the apple juice covering part of the Evian. On the right-hand side, the famous Perrier bottle covering part of the Evian bottle. That's further to the right. So objects in front cover or hide objects behind. And one more image that does this with Jacob Lawrence's cabinet makers. And so definitely you can see how some of the figures are in front and some are behind parts of these cabinets. With vertical location, this states that the higher the object is, the farther away it is. And think about stadium seating in a classroom or at a sporting event. The higher the seats, the further back the seats. This is something we see a lot in Eastern cultures, especially in Japan. And we've got this beautiful Japanese panels here where we've got the Japanese iris. And you can kind of see they're at different horizon levels. The higher the object, the further back it is, and it makes it look more like a three-dimensional scene. We see this in the art of India. And we see it also in pop art from the 1960s. In this collage, we've got some cans of coffee, and it looks like maybe a pork roast up front. Further back, a glass of beer, camera, soda, and then further back yet, the lemon and the apple that looks to be on a windowsill. So on an exam, I might ask, how is this space created? You would answer vertical location, or I might ask, according to the law of vertical location, which is furthest away from us? And that would be like the lemon and the apple. We also see it once again with the cabinet makers. The higher the object, the higher the person, the further back it is. Now we get into the world of perspective. And atmospheric perspective is sometimes called aerial perspective. The definitions here are a lot more intense. They're a lot more heavier. However, what we need to do for terms like this is to be able to identify the object that is in atmospheric perspective. So don't get too caught up into the definitions, but be able to apply that term to a specific scene. But the law of atmospheric perspective is basically as forms recede into the background, their contours become less distinct. The objects take on the colors of the atmosphere. Greater color contrast is going to advance. Lesser color contrast is going to retreat. So when we see an image like this, we can see that the rock outcropping at the very base of the painting has some darker colors, a lot of color contrast compared to the white clouds around it. So greater color contrast, our eyes bring that forward. When we look out to the mountains in the background, we can kind of see that the mountains, the sky, the clouds, they have values that are very similar. And so our eyes push that further back into the distance. And that's the basis for atmospheric perspective. A lot of people say Leonardo da Vinci invented it. He did not. It was around about 100 years before he was on the scene. But he did give more of a formula to it, where he says color becomes weaker in proportion to its distance. So again, in this painting here, we have a lot of vibrant colors, a lot of color contrast that is up front, and we can kind of see the mountains in the background become very weak in terms of their colors, very light, a lot of very similar values shared. Once again, this is something that the artist is trying to reproduce. It's how we naturally see. We normally have a clear, crisp foreground, but as we go back, the contours of the objects become less distinct, and they also take on the color of the atmosphere. Up here in Yosemite, we know that those mountains in the back in the distance are not blue, but because of the water that's in the atmosphere, that's what affects our eyes. That's how we see the bluishness to those furthest mountains. It happens in color, it happens in black and white, and it has to happen in paintings as well. If it doesn't, the paintings look kind of funky. They don't look real. So we have to add atmospheric perspective to art. Now, foreshortening is sometimes called amplified perspective, but foreshortening is by far the more used term. It's also got a pretty dense definition. It says that an artist purposely reduces or distorts parts of an object, but is still able to convey the illusion of three-dimensionality. In the case of the dead Christ, this is one of the images that I call a textbook image. It is an example that all the textbooks use. Andrea Mantegna is one of the most talented artists in terms of foreshortening. And what he's done is he has basically reduced the size of Christ's torso and legs, kind of elevated the body up out of how we would normally see the body, and so that we can kind of dwell on the wounds of Christ. This painting would have been in a smaller chapel. You would sit at the base of it, and it's kind of a unique painting because I don't know of any other painting where we kind of are at the feet of Christ. Had this painting been done correctly, it would have failed because Christ's feet would have been blocking our view. So one of the important things about foreshortening is that it brings the viewer, us, very quickly into a painting at a very odd angle. And there's just a few examples I'm going to share with you because I couldn't think of very many. This is a great Baroque painting. I believe it's the Martyrdom of St. Mark, and we have this angel flying into the scene from right over our head. Mary Cassatt puts us at this unique angle at the back of this boat. And we can also have foreshortening in photography as well. Again, bringing us in at a very odd angle, so we have some very interesting dimensions that we're looking at with these works. But once again, foreshortening is very, very rare. This term, linear perspective or scientific perspective, is the most important element I'm going to talk about in this lecture. Now, linear perspective is the most convincing way of representing three-dimensional space on a two-dimensional surface. Now, we have some good news here, that it's a math equation. That's all that it is. And it's a formula. We can all follow it. So it sounds pretty simple, but we have to remember it's a math equation. And a lot of us struggle with math. So it's really important just to follow the formula. So this is a form of geometry, and it was invented by this guy, Filippo Brunelleschi. As early as 1413, he codified linear perspective. Now, Filippo Brunelleschi is this incredible Renaissance artist, and a lot of these things that we learn in the first part of this class originate from the Renaissance, and this is just some really incredible stuff. Brunelleschi is going to end up putting the dome on the Florence Cathedral. We'll talk about that during the architecture or Renaissance lecture. We're going to also see that he created the very first orphanage in Florence as well. Now, when linear perspective is invented, it revolutionizes art overnight. Everyone has to do linear perspective. And up until 1863, that's when this other guy named Edward Manet, we're going to talk about him when we talk about modern art, he says, I'm tired of linear perspective. We're not going to do it anymore. And that's going to kind of begin the modern art movements in the 1860s and 1870s. So the theory of linear perspective is simple. Parallel lines appear to converge on a single point in the distance, which means that lines we expect to be parallel are not parallel. So let me show you an example here. Railroad tracks is the best way to talk about linear perspective because we all know that railroad tracks are parallel. And if they weren't parallel, the trains would fall off the track. But it gives us kind of an interesting conundrum here where we're up in Alaska. We're traveling about 100 miles an hour. But we see that these lines, these tracks, are not parallel, that they're actually coming together at a point in the distance, and that point is called the vanishing point. So as the engineer of this train, do we pull the emergency cord because we see the tracks coming together, or does our brain kick in and say, once again, our eyes are messed up, and our eyes are bringing these lines together because we have parallax vision. Once you start to notice this, we see it everywhere. Whether you're boarding an airplane, whether you're driving home at night, whether you're destroying the Death Star, or just flying through hyperspace. Linear perspective is everywhere. You can see all these lines merging at an imaginary point in the distance. And if you don't like Star Wars, that's okay. It happens in Star Trek as well. And again, you will see everywhere linear perspective being used. So the first step in creating a work in linear perspective is creating a horizon line. And the horizon line stretches across the canvas. In fact, it actually stretches beyond the canvas as well. It is where the land and the sky are going to meet, and it is an arbitrary position chosen by the artist. When you go to a museum, they actually hang paintings to where the horizon line is the eye level for the average person. And again, it's really simple, just a horizontal line across the canvas. In this image here, the horizon line is way up at the very top of the photograph. In this painting, it's near the bottom third. But again, it's an arbitrary position that the artist gets to choose. The next step is just as easy. It's where we place a vanishing point on the horizon line. And that's really the only rule, is that the vanishing point has to live on the horizon line. The vanishing point is also an arbitrary position. So if you put, and it's very common to do this, if you put the vanishing point in the center of the artwork, that's what's called frontal recession. If it is anywhere but the center, it is going to be referred to as diagonal recession. So in this case, the vanishing point is right in the center. The idea of having frontal recession and diagonal recession shows us also the balance of the artwork. It's very easy to create a work that is in symmetrical balance, that has frontal recession. The vanishing point is right in the center, so the left side of the image can look like the right side of the image. As you see in the image at the right, it would be impossible to do that. So we would call this as being asymmetrically balanced. And with diagonal recession, it makes a much different viewpoint than the work at the left, even though it's basically the same idea of the railroad tracks. So once again, where you place the vanishing point can also determine the balance of the artwork. And we'll talk about balance in a later lecture. When we look at the painting at the left, that work is in symmetrical balance. We can take the orthogonal lines, which are the parallel lines that are not parallel, and we have a vanishing point that is going to be in the center of the work. In the painting at the right, that's going to be a vanishing point that is slightly off to the left. The key thing about the vanishing point is this is where all those parallel lines, like the railroad tracks, are going to merge. And again, the fancy name for those parallel lines that are not parallel are orthogonals. Now, the problem is that this is a math equation, and so we have to have everything correct. There's only one correct answer to a math equation. So all the orthogonals have to meet at the vanishing point. If this fails to happen, the work is not in linear perspective. So I'm going to take you over to the Santa Maria Novella, which is this beautiful church in Florence. And this is the home to the very first painting done in linear perspective. So when you walk into the church, as we are in the picture at the left, we have the beautiful altar up front. Right around the pulpit, off to the left, you're going to make a turn, and that's where we get the image at the right. That painting is gigantic. It is 20 feet in height, and this is called the Holy Trinity. It's by Masaccio. And Masaccio was the inspiration for Michelangelo. He's not an artist that we really talk about today, but he was so important. He ended up dying really young, right around the age of 27, and most likely from fever. But as a young kid, Michelangelo would go and hunt down the works of Masaccio and kind of copy them into his notebooks. So he played a big part in the development of Michelangelo early on. Now, when this was painted, so many people showed up to this church to look at this painting because it looks like this barrel vault basically extends into space that doesn't exist. It is called the Holy Trinity because we have God, the Holy Spirit, and Christ in this image. Flanking on either side, Mary and John the Baptist. The two individuals on the outside of the work, those are the patrons, those are the people who paid for the work of art to be produced. One of the ways that we can prove an artwork is in linear perspective, because this is geometry, we do like a geometry proof and we work backwards. So the first thing we do is in an architectural setting, we find the orthogonal lines. And in this case, we have the coffered barrel vault up above the crucifixion, and we can draw lines. And in the image, those lines look straight, but when we actually draw the lines, we see them coming together at a point. That's the vanishing point. When we establish the vanishing point, we can establish where the horizon line is. So again, it's just working backwards. And here we are at the church once again. And here you can see that the horizon line is right at the point where we're going to be viewing this work. Now, prior to linear perspective, this is by an artist named Giotto. And Giotto was an amazing artist. He's the very first artist of the Renaissance. There's some great things to say about this painting, but we cannot say that it is in linear perspective. Perspective is invented about 100 years after this painting is created. And when you see the image at the right and all the lines that are drawn from one side of the artwork to the other, we see that they are not meeting at a single point. They are just kind of haphazardly from one side to the other, and they're not merging at all. This is called intuitive perspective. We had an idea about perspective, but we hadn't codified it quite yet. And even when we look at works from Northern Europe during the time immediately after linear perspective is invented, it still hasn't gotten to Northern Europe. No one's able to send an email. No one's able to look online to see how linear perspective works. It traveled slowly. So it was about 70 years after linear perspective is invented for it to travel about 1,000 miles up to Northern Europe. And that's where their art starts to change. You can see, especially in the middle panel, that the room kind of accelerates away, where the roof or the ceiling is at a much different angle than the flooring, and the flooring generally looks like it's popping up rather than extending back into real space. After linear perspective, everything is mathematically precise. Is it absolutely perfect? No, it's not. And that is because we have parallax vision. We're looking through two eyes at a scene, and in this case it is just a monocular scene. It's just from one specific viewpoint. How to prove an artwork is in linear perspective? We can do it three different ways. One is just asking ourselves, does the room look to be in linear perspective? Does it look good or perfect? And the answer in this case for The Last Supper by Da Vinci is yes. It looks like real space. And without even measuring or doing anything, I could tell you this is in linear perspective. We can also look at the date. Anything after 1427 all the way to 1863, you've got a 99% chance of that artwork being in perspective. And this falls into that category. Lastly, of course, we can prove it by drawing right onto the surface. Don't ever draw onto the surface of an artwork, but in this case, we can see how all the lines from the coffered ceiling, from the tops of the doorways, from the edges of the table, meet right at the center of the work at Christ's forehead. We can establish the horizon line, and once again, a very balanced work, and you'll find a lot of religious works being in symmetrical balance. In Boston Common at twilight, we can also measure through linear perspective and see that all the trees are planted in a row. All the park benches are in a row. The sidewalk, the edge of the street, the balconies in the buildings at the left, they all line up to that single point, the vanishing point. And ironically, if you go to Milan and you see The Last Supper, people stand right at the center of this work. We subconsciously stand at the vanishing point. In this work here, which is at the Museum of Fine Arts in Boston, everyone stands off-center to the left. Again, we just stand at the vanishing point naturally. So here are the key terms that you need to know about. We've got the horizon line that separates the land from the sky. We've got the vanishing point. That's where all the orthogonals are going to meet. And then the orthogonals are those parallel lines that in the case of art on a two-dimensional surface, they are not parallel. So what we've just gone through is one-point perspective, and that means that there's only one vanishing point. But what if we add a second vanishing point? Well, then we get two-point perspective. And the idea here is that we can see a building or similar object at an angle. It gives the artist a lot more versatility. As you can kind of see from the one-point perspective at the left, it tends to be a very flat, very frontal scene, compared to the image at the right, where you have much more of a three-dimensionality and a whole bunch of different choices in terms of creating these objects. So immediately looking at this building, we can say that it's in two-point perspective. If we were to take lines and follow the rooftop, follow the racing stripe at the base, following the line that's in between the two windows on the right-hand side of the building, everything meets at a single point way off to the bottom right of this artwork. And we know that we're correct saying that it's in linear perspective because that's also where the horizon of the work is, down at the very bottom. Now, this artwork is unique because if we do the same thing to the left side of the building and include as well the tops of the gas pumps, that we have lines that merge off the center, off the canvas themselves. So here, remember that the horizon line extends past the edges of the canvas infinitely in either direction. And the artwork here on your screen is probably the vanishing point about 3 inches off to the left of the image. But again, a vanishing point was used, and this is in perspective. Now, Ed Ruscha is unfortunately the last of the pop artists that is still alive. He is a Southern California artist. I'll show you some other images by him later in different lectures, but he absolutely loved this gas station. He painted it during the day, he painted it at night, he painted it on fire, and my favorite rendition of this work is the double standard that he created. So wrapping this up, with Paris Street on a Rainy Day, it kind of covers everything that we've talked about in this lecture. The artist's name, by the way, his last name is pronounced Caillebotte, and he is a post-impressionist artist. The work here shows us scale. Objects closer to us, like those people walking toward us at the right, are larger than those further away, such as the gentleman with the umbrella just off to the left. We also have overlapping. In the far left, you have 2 gentlemen under an umbrella, and one covers or hides part of the other gentleman. So we have overlapping. And then we also have vertical location. Those people walking toward us, we don't even see the lower portion of their legs. Off to the left, that person's a little bit higher in the landscape. Off to the left again, those 2 individuals walking away from us, they are also higher up than the other person. So vertical location is present here. And when we look at that building off to the left, we know immediately it's in 2-point perspective. And again, we can prove that by drawing lines down each of the balconies. We have 2 points on the horizon line, and we have a work that's in perspective. It does get worse. Now, we can have a third vanishing point, and this then becomes multi-point perspective. The only thing I would really want you to know for this class is that, yes, it does exist. I am not going to make you do multi-point perspective, but the idea is that we've got 2 vanishing points on the horizon line, the third above or below the line, and it makes images such as this. Now, M.C. Escher is a really famous artist. And I hesitate when I say artist because the artist community really doesn't like him. He's kind of pushed off to the side as a novelty. But I would argue that I think these artists are jealous of this individual's talent and ability. The thing is, M.C. Escher did not start off as an artist. That's not his profession. His profession is math professor. And so linear perspective being a math formula and him also having, artistic capabilities, he's able to create these really cool worlds that kind of mystify us. Now there's one last term I'm going to cover, and that is trompe l'oeil. It is a French term, and it literally translates into to fool the eye. I would define it as visual deception, and it's where objects are rendered in such incredible detail that they commonly emphasize the illusion of space. And when we have a church like this that is built back in the 1600s. This is St. Ignatius in Rome. And we walk in through that middle doorway, and we're going to end up with all the other individuals sitting in the gallery. And we look up at the ceiling, and we would normally have a barrel vault, basically a series of arches over our head. But in this case, the arches are basically vanished because of all the paint. And this is trompe l'oeil. So the ceiling has disappeared, and now we see the glories of heaven. In fact, we see St. Ignatius just off center to the left, and he's being assumed into heaven to meet Christ. They're basically right at the center. So this is a standard stock photo of what this church looks like. This is a real photo, so you can see it's much more vibrant in color and even more kind of illusionistic. It's just an incredible sight. This is Andrea Mantegna's work here, and we're in this beautiful ballroom in Florence, Italy. And we look up and we have individuals looking back down at us. Again, this is trompe l'oeil, and trompe l'oeil is also affected through foreshortening. And this is Mantegna, who is famous for that Dead Christ painting and just a master of foreshortening. And that's how this image works. We have the trompe l'oeil niche, which is probably the image on your study guide. And this always reminds me of those emails you get of these incredible chalk drawings. This would be trompe l'oeil. And this is the last image in our lecture. So our next lecture is going to be about line.